Let's record the data. Okay, so we gathered our data, and now we need to talk about our null hypothesis for this experiment. The null hypothesis for this experiment is basically that each face is there's an equal probability for each face to be rolled out in our rolls, and for this experiment, for a six-sided die, that's 1/6, which we use. That means we use a fair-sided die. The alternative hypothesis for this experiment is that it's an unfair sided die, and that each face doesn't have the same um, probability to be rolled out. Uh, for our data summary, we have that we gathered here is for face one we have, for example, 21, 2, 26, 3, 23, 4, 33, 5, 25, 6, 22. And for this experiment, all of our faces had an expected value of 25 because we did 150 rolls, and 150 divided by 6, 25. So all the faces have expected value of 25. And we calculated, after we got these, we calculated it using our chi-square statistics formula, which is O minus E squared divided by E. For example, for face one, we had 21. So it's 21 minus 25 square root of 2 divided by 25. So we had like 0.64. And then like the rest of the faces follows like 0.04, 0.16, 2.156, 0, 0.36. And then we add all these up, and our chi-square equals 3.76. And before we go to the critical value, we have some assumptions that we went along with this experiment, which is the independence. This Monopoly game board dice that we used, we assume that when we roll this die, each roll is independent, so it's not the previous roll or the previous roll after doesn't affect the outcome of the next roll. And also our expected count, so we expect the value must be at least 5. So all the expected values from this experiment are 25, as we talked before. So this assumption is also satisfied. And for our, critical value, which is just square root of the chi-square calculated value, which is the 3.76 squared critical value is 9.24. And this basically explains to us that, because 3.76 is much smaller than 9.24, the differences between the results is not large enough to be statistically significant. So based on our 150 rolls of this Monopoly roll, there's no statistical evidence at this 10% significance level to conclude that our die is unfair. So our results indicate that this Monopoly game board um, die is a fair die, and we can use this, and there's no faulty die.